Hey, we are back. This is Techmath2. We are looking at the final review. Yay! So the last video for the semester. So it actually starts on it's College Techmath2 final exam review, but you have to go to page 4. It says 1 of 8. You actually go to page 4 of 8. And start on chapter 15. Remember, we did the midterm, so that covered everything up before chapter 15. And I'm gonna highlight the problems that are gonna be like on the test. And I did make up a few new problems. I don't think the ones they did include are terribly difficult, but I just want to make sure you had an example of each problem that you'll be tested on for the final. All right, so only 20 questions on the final, and it looks like this. So first, chapter 15, remember that was out of the blue book, and there's a problem like all 4 of those, so 1 through 4. So let's do number 1. Write 185 equals 10, oh, excuse me, 10 to the 2.2672 power as a log equation. So we're going to write that as a log equation, which means remember how this works. Log base 10 of 100 is 2. Logs are just a fancy way of writing exponents. So if you think of it as 10 to the 2nd power, that equals 100. And so if you keep that in mind, that's all we're going to do. We're going to just do that to this. So log base 10 of 185 is 2.2672. So just like this, the power went over by itself, the power went over by itself, the base went on the log, and then the number was after. So just those components, we just rearrange the components. If you want to ditch the 10, you don't really need the base 10. If you just have LOG, then it's known in mathematical circles that that's base 10. All right? Okay, let's look at number 2. ln of 9.31 is equal to 2.23. It says write as a power E equation. So again, just what we're doing here, but now we're going from log. Remember ln, that's log base E. And it's just the reverse of what they had us do there. So E to the 2.23 is equal to 9.31. And you have to have that equals 9.31 on there. So make sure to write the equation. Lots of people just say, give me E to the 2.23, and then they lose a couple of points. I don't want you to lose points on it. Make sure you write the equation, which means equals, and then the number also. All right, number 3 is they give you a formula, and then they give you the 2 values inside. So this is just a calculator problem. You just substitute in the values. So 47.6 divided by 61.3. All in your calculator, so parentheses, and then a little caret, that's the power, 0.6. And then just hit enter, and round, make sure you round. So this one is to thousandths, so 0.859. All right. And then there is one just like number 4, which is another just plug and chug, just a calculator problem. It's a little more complicated than that one because you have to use E. So that is second ln, and then it'll pop up an E to the power. But in general, those plug and chug is usually pretty straightforward. So B is equal to K e to the negative CT, and they want you to find B, so they give you the 485, you do times second ln, that pops up e to the power and puts a parenthesis on it, and then, now this is a little tricky, so you don't enter it wrong, you do this 7.2 times the point. Oh, there's supposed to be a negative in front of it, so throw negative 7.2 times 0.096. So don't forget the negative. If you did forget the negative on the 7.2, you could put it there. Or you could, putting it in front's kind of a pain because that parenthesis pops up automatically with the E. So it's easier just to put it there, negative 7.2. Times 0.096. Or if you already typed 7.2, then just do times negative 0.096, just so the power ends up negative, because they've got a little negative right there. All right, and then you just hit enter and round to a whole number, so that's 243. Okay, then we're on to chapter 11. There is one like 6, or rather number 1, A and B. So let's take a look at that. So they give you this equation, y equals 5 sine theta, and then they ask for the amplitude, so you'll have to be able to find that for me. And then they ask for how many cycles there are between 0 and 360. So amplitude is the number in front, that's just 5. Cycles, since there's nothing in front of the theta, it's 1 cycle. So just 1 cycle happens there. Be careful, because on the chapter 11 test, as I recall, a lot of people got that wrong because they gravitated towards the 5. Now, if there were, let's say there was a 3 theta, then there would be 3 cycles between 0 and 360. If it said 9 theta, then there would be 9 cycles between 0 and 360. All right? So, if there's no number in front, it's just 1 cycle between 0 and 360. One regular sine wave. Then the next one, so they have it at 90, at 180, at 270, like where you're plugging in those values and just kicking out answers. There aren't any like that on the test. So if you look at number 2, write an equation with y and theta. Again, you could use y and x if you're typing it out. That's fine if you decide to not do theta and just use x, because theta is kind of a hard thing to type into. So I might even rewrite that question to say use theta, use y and x, and write the equation so you don't even have to worry about finding theta, or like the theta key, if you will. So 2a, there's one like 2a, there's one like 2b. Here they tell you the amplitude is 12.6, and it's in phase with y equals sine theta. Well, what that means is you just do y equals 12.6 sine theta. So that would change the amplitude, but it wouldn't shift it right or left. There wouldn't be more cycles or anything like that. There's also one like 2b, a sine wave harmonic with amplitude 18 and 5 cycles between 0 and 360. So again, they give you the amplitude of 18, but they also say 5 cycles. So it's going to be y equals 18 sine 5 theta. Okay? And remember, theta, that's just a variable. So if I say y and x, then you just say y equals 18 sine 5x. All right? Okay, and then there aren't any which of the following has the same graph as that. Let's look at then chapter 12. Chapter 12, there is not one like number 1, but there is one like 2 and 3 and 4, and I had to make one up because they didn't have one that's like on the test, so I made up one called 4.5. So we're on chapter 12. This is on page 5 of 8 on the final review. So in chapter 12, we're looking at 2. There isn't one like number 1, there is one like 2. So convert log A equals B to a power 10. Power 10. Remember, there's a 10 here. So we're going back and we're just saying 10 to the power B is equal to A. So you're just converting it from log into exponential form, 10. All right? Power 10 equation. Don't forget the equal sign. 3, solve for t. So this one we actually have to solve. So you could do this 2 ways. The way that I usually explain it is I say take the log of both sides. So you do the log of 500 and the log of 2 to the t power. Now why? Why would you take the log of both sides of an equation? Well, because remember there's a rule. When you have log to a base, not log base 10 to a number, whatever power you have there can be dragged down in front. So now we have t log 2 is equal to log 500. And now we're one step away from being done. We divide both sides by log 2. Divide both sides by log 2. What I want you to do right now is do this on your calculator. Because when you type it in, log log 500, you have to remember this end parenthesis. Very important. Muy importante on that one. Divided by log 2. That last one, it doesn't really matter if you do the parenthesis or not. I usually do it anyway. But, and then hit enter. And then we round to the nearest hundredth. So what are we looking at there? That is 8.9657, so we'll call it 8.97 is t. All right? Don't forget that second parenthesis. That's why I wanted you to check it into your calculator right now and make sure you get that. If you omit that parenthesis, you will get the wrong answer. And it's really tough to, you can't really check these very well. I guess you could pop it back in 2 to the 8.97, but it's not going to be exactly 500 because we rounded to hundreds. So when you check back, don't expect it to be exact because we rounded. All right? Okay. So let's do also number 4, and then I'm going to make one up right on the spot here. Well, I already made it up and put it on the page, but I'll work out the made up one and explain how to do that. All right. So we are looking at number 4, solve for n, when we have k times log a to the nth equals p. So this is actually easier than it looks. They said solve for n. So n, if you already have the log here, you can pull that down in front. So we have k times n times log a equals p. And now, all of these are being multiplied. K times n times log a, that's all being multiplied, and I want to solve for n. So I just divide everything that's not n. And I'm done. So that one is tough to get your head around because it's very abstract. It's all letters. But as far as, working it, it was only kind of 2 steps. Just drag the n down front and divide out everything else, and you're done. All right? So now let's look at the made up one. So I made up one, I called it 4.5. Anytime there's a decimal, you know what, I just made it up. So on the test, they say use this formula, E2 over E1, and then they give you E sub 1 is equal to 0.03, E sub 2 is equal to 14, and round to a whole number. So find D and round to a whole number. So really, it's plug and chug. Again, I figured everybody in this course could handle that, but I don't like surprises on the final exam. So I want everybody to be prepared. So 20 times, I've just typed this into my calculator. E sub 2 is 14 divided by E sub 1, 0.03, and parenthesis, hit enter, and round to a whole number. So that comes out to be 53.38013.562, and that's just 53, whole number. All right. Then we're on to chapter 13. So chapter 13, 1B is going to be on the test. There isn't one like 1A. There is one like 1B. Find R round to tenths. Okay. So let's see, they have ln r is equal to 3.65. And they want me to find r and round to tenths place. So to find r, we'd have to think about it as a log base e of r, 3.65. And now to find this missing variable, we're going to have to write it as an exponential. So e to the 3.65 should equal r. And then we just do that. E to the 3.65 is, you pop that into your calculator, that's second ln, that kicks out 38.47, ... and we'll do 38.5 to tenths place. Okay, now I made up one, and it says convert to a log function. Equation rather, not function, equation. So convert to a logarithmic equation. So that means we need that equals to sign. Do not just give me part of the answer here. So what we do here is we can write log base e of 9897 equals 9.2. You absolutely positively need the equals the power, and that's good. Otherwise, you could write ln 9897 equals 9.2. This is also fine. In fact, this is probably easier to type into Blackboard on the test, because log base e. Most of you just type log and then put the little e there and then put parentheses, and I get what you mean, and that's fine. But this is even easier if you just go ln 9897 and equals 9.2. Don't forget the equals 9.2. I can't tell you how many people lose 2-3 points for just telling me ln 9897. And they forget about the equals 9.2. When they say equation, you need the equal sign. Otherwise, it's not an equation. It's an expression. All right. What else? They did one just like number 2A. So let's do that. Still on chapter 13, on the final review. So 2a, it says solve for r, and ln d over r is equal to negative kt. Okay, and we did have one very similar to this on the test you just took. So let's go over the couple of answers. Now, instead of splitting it into two different log base e's, don't. This one is easier if you don't split it up, I think. I think one or two people did split it up, and I mean, it's fine. They still got the right answer, but a few more steps if you split it up. So let's not. We're not going to do the ln d minus ln r, even though that is a legitimate substitution. We're going to go like this, and now we're going to e to the negative kt is equal to d over r. So from here, we're trying to solve for r. So you could cross multiply and solve. So what I did, and this is probably because I'm a math guy, so at this point I said, wait, we got a negative exponent. I'm going to pop that down to the bottom and then make it positive. So this is going to be 1 over e to the kt. So I moved that to the bottom and got rid of the negative. dr, and then cross multiply and solve. So then we have r is equal to d e to the kt. And you're done. Now, some of you didn't do that, which is fine. You still got full credit for it if you left it like this, d over e to the negative kt. I still gave you full credit because there was nowhere where it said no negative exponents. So this and this really mean the same thing. Think about it. If that's on the bottom and negative, I could move it up and make it positive. It would just be that. And what you did there was then you just went right into cross multiply and solve mode and got this, and then divided the e negative kt on both sides. And there, voila. So either one is fine. All right, let's look at the next one. Ooh, the next one is a little involved. Because they put the thing that we're solving for up in the exponent, which makes it tough. That means you have to do the log of both sides to pull that down and solve. It's a very common trick we use in algebra. All right, so it is like number 4 on chapter 13 here. B is equal to k e to the negative cv power, but then they don't tell us to just find b. If they just told us to find b, it would be back like on the first page, and you just plug and chug. This is a little more difficult than that because they gave us the 135, they gave us the 542. They didn't give us v. Ugh, that's up there. So the first step of this is actually isolate e. You want to get e by itself, which means divide both sides by 542. All right? And so when you do that, that's kind of ugly. So I'm going to leave it so I don't have to write out that big long decimal every time. I'm going to just leave it like this for right now. 135, 540 seconds is equal to e to the negative 0.0337v. So now we have e all by itself. But we have our variable up in the exponent. We want that down. So what we're going to do is we're going to take the natural log of both sides. And now, I've had that question fielded in class. They're like, well, wait a minute. Why the natural log? Why not log? Well, anytime you've got e in the equation, you want to stick with ln. Anytime you have, just numbers, or especially 10, you want to stick with log base 10. Okay, and you'll see why right now. You pull this down front. And now we got negative 0.0337v ln e. Well, the natural log of e is asking e to what power gives you e? That's 1. So ln e is just a 1, which that's why it just disappears out of my work, because 1 times that is just itself, negative 0.0337V. And now we can do the log. I think I did the log finally here on my work. Did I do the log of that? Oh no, I just left it 0.2, so I did the 135 divided by. So here. Now, you still have to find the answer for me. So now when you type that in, it's ln parenthesis 135 divided by 542, end parenthesis divided by negative 0.0337. And then hit enter, and that will give you 41.24603036, but they only want tenths, so 41.2. So pretty involved problem, a lot more involved than the one on the first page where we just had to pop that in and that in and that in, and then hit enter. This one, lots of algebra involved. We had to divide up the 542 to isolate the e, take the natural log of both sides to bring that variable out of the exponent into the regular world here, and then divide by the number in front, which wasn't very pretty either. That's the problem with real life problems. A lot of them are not very pretty. Okay. So now let's take a look. Oh no, gravity. Chapter 14. And I think we're on to another made-up problem that I had to make up for you. It's on the exam, but it wasn't on the review. We called it 1.5. Find the equation of the line through 0, 0, and 14,3. Now, actually, we do use this specifically in statistics quite a bit because if you know your system is linear and you have like an equation, or you have this raw data and you plot the data and it looks like a line, you can do what's called a regression line, a least square regression line, to try to hit as many of those points as you can, and then you pick a couple of points off the line and have to generate an equation. And so this is actually kind of real world stuff. Now, there's two different equations we're going to use. We're going to use the slope, which is the change in y over the change in x, and we're going to use point slope form, which is y minus y sub 1 equals slope and x minus x sub 1. All right? So first, we find the slope. So the slope in this case is 3 minus 0, that's y minus y, over x minus x, over 14 minus 0. So this was like x1, y1, x sub 2, y sub 2. That's how that fits. So the slope is 3/14. Oof, not very pretty slope. Now, we only need 1 point. You needed 2 points to find the slope, but you only need 1 point to find the equation of a line. So I have the slope, I have this part of it, but I only need one of these 2 points. So always get rid of the one. If there's negatives in it, I usually toss that one away. If there's a 0, 0, like an origin, go with that. It's super easy to sub in and work with. This one is what I'm chucking away. So minus 0 and x minus 0. Well, y minus 0 is just y. And then 3/14 times x minus 0 is just 3/14 x. And we're done. That's the equation of our line. Now, let's say, oh, Mr. Pledge, I didn't do it that way. I chucked away the 0, 0. No worries. You'll still get the same answer. You'll just now have work to do. So look, if I put in that as my x and that as my y into this equation, meaning I use that point instead of 0, 0. Now I have some work to do. I should solve it for y. So y minus 3 is equal to, you have to do the distributive property. And remember how that works. 3 times 14 over 14 times 1. So we have 3/14 x. What is that? 28, and then another 14 onto it is 42. So minus 42/14. Okay, yeah, top times top, 42, bottom times bottom, 14. But that reduces. 42 divided by 14 is 3. So we have this, y minus 3 equals 3/14. X minus 3, and now we solve for y. So add 3 to both sides, and what do you know about that? Same equation, more steps. So that's what I mean. If you have 0, 0 available, pop that in as your point instead of the other one. Okay? So yeah, that one, I don't know why they didn't put one like that on the review. That's a pretty involved problem. And it would have been out of the chapter 14 homework. None of the other ones land on the test from chapter 14. The parabolas and the coordinates and all that. So, and then the last thing is the stats stuff, which was just on the last test too. So hopefully that's fresh in your mind here. That's also from chapter 14. So find the mean, median, and mode. I didn't put the find the standard deviation here on the final. You should be aware of it. We usually use that in like kind of higher level statistics is when you're playing around with standard deviations. It's very tedious to find and not a lot of exposure I think you'll have with that in the future unless you go to stats. So the mean, the median, and the mode. And so that's what those are going to look like, 7, A, B, and C. Those are on the final. About the same amount of numbers, like less than 10 or less numbers. I think that maybe 8. But anyway, so even if it's 10, that's not too difficult. So remember, how do we find the mean? We add up all those numbers and then divide by 10. So that turns out to be 163 over 10, which is 16.3. All right. The median is trickier, and a few of you messed that up on the test. Don't mess it up on the final. So you put them in order. There's 10 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And now we want the exact middle. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. There's not an odd number of numbers, so we have to average the two middle numbers. So 15 plus 18 divided by 2. And I think what some of you did was you took the raw data and counted to the middle and found the middle of those numbers. Well, you have to put them in order first. You can't have them all discombobulated and then try to find the middle, the exact middle. So what does that add up to? 33 halves, which is 16.5. So there's the median. And then the mode is the one that occurs most often. Now look, there's 15, 15, 15, and there is 19 and 19, but this one occurs 3 times. This one only occurs twice. It is not a tie. This is not bimodal. It's just 15. So it isn't just if it's repeated, it's what's repeated most times. Now, if there was a third 19, then it would be 15 and 19 if it was a tie for first. But if there's more of one than the other, it's just that one. And again, most people got it right, but a couple, 1 or 2, did make that mistake. All right, and so I don't want you to repeat that mistake on the final. All right, so that is what the final is going to look like. Good luck.